to download the Microsoft Teams application so that you don't encounter any issues on the webinar. And then if you have any questions though, please post it in the Q&A sessions in the right-hand corner of your screens. All right. So for our common questions and FAQs, so for those attendees who have registered, you'll be able to receive a copy of your slides and video recordings via email, right? So since you have registered, it will be sent to your email. So please check please check your junk mails. Probably it state there. So just wait for it for the next 2 business days. And yep, there will be a certificate of attendance. It's a free digital certificate of attendance for those live attendees for this technical topic. So there will be there will be a link and QR code that will be provided to you at the end of the session. You will need to complete a survey form for you to be able to receive the digital certificate of attendance. All right. So for those who are new here, I would like to introduce myself. All right. My name is Marvin, one of the course advisors here at EIT, that's Engineering Institute of Technology. We are actually an education provider based in Australia. Our main campus is in Perth. And we also have a campus in Melbourne, in Victoria. We also have a recently opened campus in Brisbane. All right. So EIT has been an education provider offering engineering courses. So we have a wide range of programs. So we start from our professional certificate courses, going to our diplomas, advanced diplomas, undergraduate and graduate certificates. We also have bachelor's, master's, and doctor of engineering courses. All right, so these programs are industry-oriented programs, which is designed by industry experts, ensuring that our graduates has the cutting-edge skills that are valued by employers. All right, so our programs as well being accredited by the Australian government. And at the same time, we have programs that are recognized under 3 international engineering accords, namely Sydney, Dublin, and Washington Accord. All right, so these programs are being delivered by industry experienced lecturers like our presenter today, Dr. Vishal. They are very knowledgeable in terms of this, and they're not only teaching, they're actually working in the field as well. So they are experts in this engineering experts. All right, so these programs as well are being delivered by through a unique delivery methodology, all right, which makes use of live webinars such as this, and then also with our international pool of experts lecturer. We also have a dedicated learning support officers and state-of-the-art hands-on workshops, remote laboratories, and simulations. All right. So for today's topic, from concept to creation, this is about exploring 3D printing's present and future pathways. So this is a technical webinar which be delivered to us by Dr. Vishal, our senior lecturer and Doctor of Engineering coordinator. All right, and he'll be introducing himself soon. All right, so yep, thank you so much, and I will hand over the floor to Dr. Vishal to introduce himself. All right, Doc.
Uh, Thank you, Marvin. Let me take control. Okay. Okay, I think am I audible? Okay, thank you. Okay, so my name is Vishal Sharma, and I am currently working as a senior lecturer and a research coordinator at the EIT's Melbourne campus. I have about 25 years of experience in teaching and advanced manufacturing research, and I have published over 100 articles, which is having a citation, more than 4,000 citations, and earning H-index of 38. I am among 2% researchers as recognized by Stanford study and hold NRF rated researcher rating in South Africa. My career has taken me to France, South Africa, Norway, and Poland. I serve as associate editor of 3 prestigious international journals. I've also mentored 14 PhDs and 30 master's students. I have organized 7 international conferences, edited 3 books, and coordinated 6 short-term programs with international faculty. I have also completed three industry projects. So this is a brief about me. Now let's proceed into the topic. Now the topic is 3D printing. So from creation to concept, exploring 3D printing's present and future pathways. Now, if I would like to show you just two products. So these are just two products which we have produced here in our lab. One is sort of a glass or cup. The other one is the it's a mobile stand. So you can see I can keep a mobile on this. So this the other one is a mobile stand, and first one is a cup or glass. Now, so what we intend to cover in this session is, so we'll start with the basic concept of manufacturing, and then what is additive manufacturing? Because the title of this presentation is 3D printing. So what is 3D printing and how 3D printing is related to additive manufacturing? We'll be talking a little bit about that. And what skill set you need to have if you want to produce these components. What skill set you have, what technologies are existing, and what technology we should be using. And the third thing is, do we really need to make these designs on 3D printers? So all these questions will be answered in this presentation. So I'll be also talking about different additive manufacturing technologies. So definitely I'll be talking about some research topics. And if somebody is new and wants to learn about additive manufacturing, then towards the end of the presentation, I have put some slides where resources are given. So this is all what I will be covering in this session. Now coming to manufacturing, what is manufacturing? Manufacturing is the process of converting raw material into finished goods using various techniques, processes, and machinery. So manufacturing in general, we can categorize in two types. First one is called subtractive manufacturing. The other one is additive manufacturing. Now, what is subtractive manufacturing? The conventional way of doing is subtractive manufacturing. Suppose I want to create a sphere or ball, something like this. So I start with the raw material. The initial shape is like this, and then I machine this part in order to obtain the final shape. So when I'm doing machining, basically I'm removing the material. So that is why the name is subtractive manufacturing. Now, in contrast to subtractive manufacturing, we have additive manufacturing. So so as the name says, so we are not removing the material. Here we are adding material layer by layer in order to produce a certain shape or a certain part. So when it is subtractive manufacturing, so what we end up getting is a lot of material is wasted as compared to additive manufacturing. Additive manufacturing waste material is quite less as compared to subtractive manufacturing. Now, as I said in the beginning, the additive manufacturing, it's a it's a category of manufacturing, subtractive and additive. Now, what is 3D printing? 3D printing is a general term which is used by laymen, but in technical domain, we always say it is additive manufacturing. So additive manufacturing is umbrella. Under that umbrella, we can have 3D printing. So in this presentation, mostly I'll be saying additive manufacturing. So whenever I say additive manufacturing, this is a 3D printing. So I'll be following the technical term. Okay. Now, as per ISO standard, so what is the definition of additive manufacturing? This is the process of joining materials to make objects from 3D model CADs using layer upon layer. So as opposed to subtractive manufacturing. So you can see here in this figure. So what we intend to. So what skills? So what are the steps basically? So again, coming back to the same example, I want to produce this part. So how do I start it? So the first starting point is CAD model. So you will be creating a CAD model using any standard CAD software. And once the CAD model is ready, next step is, so you'll be creating a STL file. So STL file, so this is a standard tessellation language file. So from the CAD file, from the solid model CAD file, we are creating the STL file, and from the STL file, we are performing slicing. In slicing, we are generating G codes for the motion of the extruder. And once this is done, this file is taken and it is put on the machine. And in the machine, when we say 3D printer, so this is a 3D printer. So there are different technologies. I'll be talking about different technologies in the subsequent slides. So we take that G code and insert it, put that G code file on the machine, the part will be printed. And once the part is printed, the game is not over yet. So we have to do some operation even after that, which is called post-processing. So we need to do post-processing. Once we do some kind of post-processing, our product is ready. So these are the steps. So always the starting point is my CAD file. So I start with the CAD, and the remaining intermediate steps are done in the software. There are different softwares available. So these are done in the software, different softwares, and finally we are able to produce the part. Okay, so what skill set I should have in order to work in this domain? So I should know how to create a solid CAD model. So that is the skill set I should have. Now, what is the advantage? So I can create very innovative designs. This technology, I will not use any tool for cutting the material. So no tool is used. Another advantage of this technology is I can produce fully dense part or porous parts also. Complexity, so complex designs I can handle easily. I can customize the parts, and the skill set required is only I should be able to create a CAD model. So the CAD model is the starting point, and most of the things after that are done in the software environment, and it is quite easy to work in this domain of 3D printing. Now, I have one question there. So if things are so simple in 3D printing, do you think that 3D printing will eliminate conventional machines? So you can give a reply in the chat box. Please, you feel free to use the chat box to give your reply. Do you think the conventional machines? So conventional machines, we're talking about lathe machine, milling, drilling, shapers. So all these are the conventional machines. Do you think these machines will be redundant because of this additive manufacturing? So towards the end, you will get the answer of this question. Okay, so another question. This one is quite interesting. Uh, okay, thank you for your reply. Now here, if you see, uh, we have, so I have listed listed four parts here. So four different designs. So first one is a metal bracket. Second one is again, so this one is a metal bracket. Another one is also a metal bracket with different design. The third one is a plastic hanger and a plastic gear. Out of these four, can you pick which one is the best suited for 3D printing? Out of these four designs, can you pick which one is one or two you think are the best candidate for 3D printing? Again, you can use chat box to reply. Okay, so towards the end, okay, thank you. So in fact, the 3D printing technologies which we have currently, we can manufacture this also, and this as well as this. So all these different designs can be manufactured on our 3D printers. We have uh, 3D printers for metals, we have 3D printers for polymers, and for composites as well. Now, so for example, should I be producing this part, say part A on 3D printer? If yes, which 3D printer should I use? So all these things you will get reply of all these things in the subsequent slides. Okay, so now this slide is quite important just to show you the importance of 3D printing. So at the moment, more than 200 universities worldwide are actively engaged in research in the domain of additive manufacturing. So I'm particularly inspired by two universities, University of Illinois and RMIT University. This is situated at Melbourne, quite close to my location. Both these universities, they are focusing their research on creating parts which are porous structures. So you can see here these are the porous structures. The main advantage of making having porous structure is will have the part will be lightweight, so we'll be saving the material. Part is also light. So these are the two advantages. And if you see here the kind of structure which they are making, this is something like a lattice structure or gyro designs. So such kind of designs we are also making in our labs. You can see here. So we have created a lattice structure, and the other one which I'm holding is the gyro structure. So all these structures which these universities they're trying to work upon, we are also doing it in our lab and performing some research on these structures. You can see another one, a porous structure. This is the gyro design. Okay, so the main focus is on the design here. So we'll see what else could be done in the subsequent slides. I'll be showing you what more research could be done in this domain. Okay, now first things first. Now, what is this additive manufacturing and where it is used in industry? So for that, so we have to see this figure, which is quite important, and you will hear this word quite frequently, Industry 4.0. So Industry 4.0, so let's begin with the Industry 1.0. So 1.0 means this is first industrial revolution. So in the first industrial revolution, if you see the timeline here on the bottom side, so towards the end of 18th century was the time for the first industrial revolution, and the main source of power was steam. In the second industrial revolution, the main source of power was electricity. This happened at the beginning of the 20th century. And from 1970 onwards, we are in the domain of the third industrial revolution. The focus in the third industrial revolution was programmable devices, robots, CNC machines, PLCs. So all these were the key attractions in the third industrial revolution. Now, what is there in the fourth industrial revolution? So fourth industrial revolution, all these machines and equipments, they are carried forward. So we have all CNC, NC CNC machines, robots, but now they are communicating with each other also. So communication is added. So we are all the devices and equipments from the third industrial revolution are carried forward. All of these devices now they have enhanced capabilities. They can communicate with each other, and we have smart algorithms working behind it, and they can the minor decisions can be taken then and there. So just to give you an example here, for example, if we talk about the industry 4.0. So you are having now, say, we take example of a bottling plant. So you have a bottle. Now this bottle will go on the first machine, and it will tell the machine, it will communicate with the machine, and it will tell what fluid to fill in the bottle, how much to fill, what cap should come on top of it, what label it should have. So this entire information is being communicated by the product. Basically product is interacting with the machine, and it is giving instructions to the machines to do some operations. So this kind of communication, so obviously when there is a communication, so for such kind of communication, we use some devices, which is one important device is called RFID, radio frequency identification tags. So this is how the tags are available on each item, and they will be communicating with the machine. So in Industry 4.0, it is product to product communication, product to machine communication, and machine to machine communication. So a lot of communication, lot of sensors, lot of data is generated. So this data is collected, and smart algorithms are created out of this data. Okay, so this is in brief about Industry 4.0. Now, when I say Industry 4.0, it is uh, it is country specific. So this was a German initiative. So when we switch to USA, they say it is a smart manufacturing, but the generic term which we should be using is 4IR, which means fourth industrial revolution. Now coming to the figure on the right side, so here again, the bigger domain is shown here, that everything is connected. And here you in the industry, you can see we are now in industry, we are using 3D printers. So this is the bigger domain. And now in industry, 3D printing is used for manufacturing the end product, which is used by the consumer or customer, that is also manufactured using 3D printers. Now, what else we can manufacture on 3D printers? Let's see in the next slide. So this one is quite interesting slide by this one company called Renishaw. So here they have given just in this figure, you can see what we can do with additive manufacturing. So they say the additive manufacturing, we can create prototypes. Prototype means you are creating the first part and then you are doing all testing on that. But that prototype is only for testing and trial. That prototype will not be delivered to the customer. Okay, so prototyping, and we can also go for tooling. So in this figure, we can see the lower part is the fixture. On top of it is the connecting rod. That the connecting rod, we need to do machining, and for doing machining, we need to hold the part. And for holding the part, we are using a fixture here. That fixture is manufactured by 3D printer. So we can also use 3D printing for direct part replacement. So in this figure, you can see initially the part was made out of, say, metal, but now the part is broken, and now we are replacing this part by another part, which is now manufactured using 3D printing. So for repairs and other things, part replacement, we can go for 3D printing. This one is quite interesting, part consolidation. If you see the figure on the top, let me clean it. Uh, this figure, if you see the shape of this figure, if I have to create this part on a conventional machine, then it will be like this. I'll create first part, second part, and the third part, flanges separately, doing machining, and then I'll be performing welding. So I will have to create different parts, and then by welding or by screws, I will be joining. But when it is produced on 3D printing, I can make it as a single piece. So the entire piece, I can make this part as a single piece. So now that's called part consolidation. So no more making in parts and then joining. Make the part in a single shot, and it is a single piece. So assemblies, sub assemblies are all gone. Now you have just one part. So part consolidations, that's the fantastic thing about 3D printing. So we can go for part consolidation, which otherwise is very difficult to achieve. Okay, so the next one is the especially the optimized designs. Optimized designs means, you see the figure here. Here, uh, only the skeleton, something like skeleton appears. So this is called um, topology optimization. So we will have a material only where it is required. Where it is not required, we will be removing the material. So this is topology optimization, and one very good software to work on topology optimization is NTOP. The link is given here. So you can create any part and then you can perform topology optimization. It will remove, it will have, it will leave the material only where it is required, and remove the material from where you don't need it. Definitely, the functionality should not be compromised. So that is there, but this is a huge domain these days. People work in this domain a lot, and if you are interested in working in that domain, then please you can use this software called NTOP. Okay, now different type of technologies. So we have 7 different types of technologies as per ISO standard. Uh, so different types of technologies. Now, if I want to make a certain part, then how I select a technology. So I will be first one. So I will be uh, okay. So these are different 7 types of technologies, and under each technology there are few more technologies available, but they are the they are related to these seven technologies. So in the subsequent slides, I'll not be talking much about sheet lamination, but I will be talking about each one type from each technology. Okay, the first technology is which falls under this category, the material extrusion process. This is a fused deposition modeling. Now, this technology is the basic technology and quite cheap. Uh, it is cheap because now it is out of patent, and the if somebody is interested in working in this domain, you can have a machine close to say about $300. You can have this machine and you can start working on 3D printing. Now, what is in this technology? What we have? So you have a build platform, and there are 2 types of material. One is called the build material, another one is the support material. These two materials, which are in filament form, they will come to an extruder. Heat is supplied, and the molten material will come out of it, and it will form. So the one layer is formed, it will be melted, and it will be deposited there. So molten material coming out of extruder, one layer is formed, then the entire bed will go down. This process is repeated. Next layer will come on top of it. So this is the process. So when you are creating parts like this, uh, so here, uh, if I have to see, I have to see what is happening here. Uh, it is something like squeezing toothpaste out of tube. So you lay just one layer. This is material coming out of your toothpaste when you squeeze the tube. Uh, then second layer, then third layer, and fourth layer. So this is how you're doing. If I see the cross section, in the cross section from this side, what it will look like, it will be something like this. Okay, so when you see the material, so this is how it appears, and it will be joining at the edges, and inside it is still there are voids inside. So with this technology, you can create fully functional parts, but you can't avoid voids, and also you will have the surface finish will be not that good, but you can create fully functional parts. Advantages, you can create fully functional parts. Technology is quite cheap and you can make use of it. So you can see here, this is something which we have created. We created an aeroplane, a model aeroplane, which of course it flies. So we have made it in the lab, and the material used is PLA. Okay, the second technology is stereolithography. This is also quite old technology and relatively cheap. If you are interested in having good surface finish, then we go for this technology. And in this technology, what we have, this falls under the category of wet polymerization. Wet polymerization is, it means that polymerization is happening in a container. So we have a container here. In this container, our material is a liquid photopolymer resin. This is a liquid material, and on top, from the top, the laser will come and ultraviolet light will fall on the resin, and wherever it falls, it will be hardened. So you can see there, this is the initial platform. So if the light falls here, it will be solidifying that portion. And once one layer is done, then the entire platform will move down. This step is repeated. So you are producing the part layer by layer. The advantage of using stereolithography is we can get very fine detailing. So very fine detailing is possible. Surface finish is too good. Aesthetics is very nice, but the parts are fragile. So the parts cannot be used. So these are not fully functional parts. These are only for aesthetics, looks, and we can try a few things on this. Surface finish is too good, but we can't create gears out of it. Gears shape and size definitely we can see, but we can't use the gear in practice because the material is fragile. Okay, so this is also relatively cheap. These two technologies are quite cheap. If you want to use, you can go ahead with that. The another technology is material jetting. So this technology is very similar to our inkjet printers. So we used to have inkjet printers a few years ago. The same technology is used here. So we have a tank. In that tank, we have a ink. So here, in this case, it is a resin, and it comes to the extruder. From here, it will be the material will be sprayed, and it will be sprayed at a point where it is required. So one layer is done, the bed will move down, the platform will move down. Again, the material is sprayed and it will fall on the place where it is required. The material jetting, so the advantage of material jetting is we can produce parts like this with different materials. In single setting, I can produce a shoe like this. So the sole is of different material, upper is of different material, and maybe inner is of different materials. So different materials. So when it is material jetting, we can use different materials. So this is advantage of this technology, material jetting. But the technology is a bit expensive at the moment. It's not that cheap when you compare it with FDM or SLA. Next one is binder jetting. So the previous to this was material jetting, where the material is sprayed where you need it. Now binder jetting is used. It is again very similar to the previous technology. Here, this is the part which we are producing, and initially we have a powder, and in that powder, so we have a material. This is a binder. So binder will be sprayed and it will bind the powder. You can see this powder is now bound, and we are able to get this. Now, initially we are starting with the powder. So it is a liquid binder. So the part which we get is something like it's like a glue. So the part is not having adequate strength. So we need to go for post processing. The post processing could be we need to keep it in the furnace in order to get the adequate strength. Now, this technology we can use for metals and ceramics. Coming to the next one, selective laser sintering. This is a quite a commercial technology. So you can see the bracket, which is shown here. It is having very nice surface finish, and all detailing is present, and we are able to produce fully functional parts when we are using selective laser sintering. This falls under the category of powder bed fusion. So what is the meaning of this is, so you have a bed, and on this bed we are having the material as in powder form. From the top, laser will come and laser will fall on the powder, and wherever that laser falls, heat is transferred there. The material, the powders will melt and they will be joining with each other. So selective laser sintering. So it will be something like this. So selectively, the laser will fall on the powder and the powder will melt and it will be joining by the it will be joining the adjacent powder present. Okay, so selective laser sintering. So this technology is used for, say, plastic materials, polymer materials, nylon, and many more. Very similar technology can also be used for metals. When it is used for metals, it is called selective laser melting. So there it is the complete melting of the process takes place. But when it is SLS, so it is only for polymer materials, and commercially grade polymer materials are used. Machines are industrial machines. So this technology is also expensive. Okay, so next one we have is the last category is uh, where we have direct energy deposition. In direct energy deposition, this is one category called WAM, wire arc additive manufacturing. Now here, this technology is used where you want to produce large parts. So if you see here, this is something like a welding machine. So you have wire fed from one side and the source of energy, a torch on the other side. So you're melting the wire and you go on depositing it. Uh, for large parts, you can see the part is huge. That can be metal parts which are large in size. We can produce by this process, direct metal deposition, and WAM is just one technology under it. If we talk about the size, most of the machines that we have seen earlier, the size is the limiting factor. We can't produce very large parts. But here, using this technology, we can produce large parts. Large part means most of the time we are able to produce approximately in the range of, say, 200 to 500 millimeters, depending upon 200 to 500 millimeters, so a cube. Uh, Depending upon the size of specifications of a machine. But here we can produce large parts also. All right. Now, so we have seen different technologies, six different technologies. And now you see here, I have to select out of those six technologies. I have to select which one out of those seven technologies, which one is apt for me. But before that, I have to select that these are the designs. So should I be producing these designs on are these designs good for me to go for 3D printing, or I can use some other method? So again, this is one example where you see this is a mobile stand of this shape, another mobile stand. So B is also of this shape. Now, out of these two, A and B, which one you think you can produce? You should be producing on 3D printing. And if you select a particular 3D printing machine, which one would you choose? So again, you can use your chat box for replying. Should we produce part A or part B on 3D printing? Okay, so now uh, let me part B. Okay, thank you. Now uh, let me pick this pen. Okay, let's say we have part A. This is again a mobile stand made out of plastic. So if I want to produce it on some 3D printer, maybe the cheapest one is FDM. Definitely, I can go for FDM. But can you tell me how I can produce this part in commercial terms? Commercial terms means how this part I can produce in mass production. what technology, how this mobile stand, which is having simple shape, a part in this case, how it is manufactured commercially. Again, you can use chat box, how it is produced commercially. Okay, so it is injection molding. So injection molding is the process how we can produce it. So injection molding, in injection molding, you have a die and you have say something like the injecting mechanism. So material will melt and it is injected to the die, and where there is a cavity you are able to produce this part. Open the die and you get the part. So when you are producing this part on injection molding, so this process is called injection molding. So maybe injection molding every 2 seconds you can produce one part. So this is the level of production rate. Every 2 seconds one part is produced. But now if you are producing this part on a 3D printer, maybe the simple design will take more than 2 to 3 hours, depending upon what is the size and what machine you are using. So you can see there is a direct comparison. In 2 seconds, one part is out. Here, 2 to 3 hours, one part is out. So when you should go for 3D printing, is your design right to go for 3D printing? So you should consider these things when we are taking this decision. And so first thing is material. What is the material? What size you want to print? How complex is your design? So this is too simple design to go for 3D printing. So if design is complex, something like this, oh, definitely we should go for 3D printing. Now, are we going for customization? So do you want to have your name printed on this? Then definitely we should go for 3D printing. If it is not a customized product, then go for conventional methods, the production methods, say the die casting in this case. So design is important. The part size, three things are important. So this is what I have listed here is from the design perspective. There is another perspective also, which is called strategic perspective. Now, for example, uh, so the part there is some assembly. So in you're creating a you're making a product, and in that you are having three parts. Now supply chain, you imagine about supply chain, you are producing one part in-house, the other two parts you are getting from other countries. Now imagine a case similar that we had, a COVID case, supply chains are broken. So now you are not able to get a part from other countries. So what to do? Even though the part design is too simple, so what to do? So in that case, definitely you have to go for 3D printing because now supply chains are gone. So strategic decisions are also important. Supply chains are lost. How much is the volume? What is the schedule when you have to deliver it to the customer? Another thing is also important, design iterations. So how many times you'll be making changes in this design? So those things are also important to decide whether I should be producing this design on 3D printing or not. So what you see here, this I have taken from a very good paper from Purdue University. So they have given a nice technique to they have given, they say it is a scorecard to decide if a particular product is good candidate for 3D printing or not. So they have given nice guidelines. You can use go through this paper, and then you can take a decision whether to make a particular part on 3D printing or not. All right, now so coming to some research aspects in additive manufacturing. Here, now in additive manufacturing, as I said, so there are three parts. First part is design. So you can do something in design. Second is related to material. Definitely you can do something there. And then method, which technology you're using. You can definitely do something there. And above all, you can definitely do something about modeling. Now, for example, when I say the design related issues, so you can see here in this figure, there are many designs, bio-inspired designs. So this design is, say, inspired by the trunk of elephant. This design is inspired by, say, a bat, and the train front portion of the train is inspired by a kingfisher. So bio-inspired designs. Uh, there are many bio-inspired designs which are very difficult to produce. So another design could be, say, honeycomb structure. So if you see honeycomb structure, it is very difficult to produce honeycomb structure using conventional methods. So there I don't have any option, no option there to use conventional methods. So I have to go for 3D printing. Another beauty of 3D printing is, so when you go for topology optimization, so this I touched upon topology optimization in the beginning also. Initially, you are starting with a part like this, which is having this design. When you apply topology optimization, so now the material is reduced and the material is now only available where it is required, but it is not compromising the functionality of the part. So there also 3D printing is a good candidate, and the software again I'm reiterating here the NTOP topology optimization. If you want to work with topology optimization, NTOP is a good software. Okay, so different designs. So you can go for different designs. So a lot of scope for research there. Material development. Those who work in the domain of materials, they might be familiar with this figure, very important figure given by Professor Ashby from Cambridge University. Here on x-axis, you can see we have density, on y-axis, we have the strength. So this graph is for all materials, but uh, when we talk about 3D printing, so we don't get that much range of materials. So we get the type of material that we can use on 3D printing is limited, just few materials uh, under each category. So there is a lot of scope for development of new material also. So we can work in this domain, which is called whole area, where so we want to have make part light, at the same time it should have more strength. So we can work in the domain of material development for 3D printing. So that is another aspect of research. uh, the next one is related to the technology, which is my favorite one. Here method. So we had different technologies. So 7 technologies. Under 7 technologies, again for the subheadings. Now for on each machine, we can try different process parameters and see what is the quality of the product that we are producing. Quality could be, say, mechanical properties. It could be dimensional accuracy, say surface properties, residual stresses. That could be many other properties as well. So what is the effect of process parameters on the product quality? So this is again a huge area where a lot of scope of research is there. Last but not the least, modeling. Modeling aspect can never be ignored. So modeling and optimization. So let me go to the next slide. There, I'll show what some of the studies that we have done in the past. So modeling could be of 3 categories. One is called empirical modeling. This is basically experimental studies. Second one could be analytical modeling, where we use physics-based modeling, and third could be machine learning algorithms. So in the past, we have done these studies, empirical studies. Now, if you see, this study was done on SLS machine, selective laser sintering machine. So what we did, we changed the input parameters, the process parameters, and we observed the effect of process parameters on the product quality. And finally, we went for the optimization. So what are the process parameters? What are the best process parameters in order to give us the best quality of the product? So such kind of studies can be done. Uh, Quite important from practical aspect. And in industry, they do a lot of studies like this. So this study was done on SLS. Another similar study was done on FDM, fused deposition modeling machine also. Now coming to analytical modeling, this is physics-based model. So you can see here in this figure, this article is quite important if you are interested in studying what is the physics-based model. Physics-based modeling could be, so you imagine there is, this is the filament. I provide certain heat to the filament. So how much heat I should give so that it forms a drop, and then this drop will move with the certain velocity, and below we have a substrate. On that substrate this drop will fall and it will be spreading like this. Then in the meantime more heat goes, next drop is formed, that drop will also move with certain velocity and it will be sitting on top of it. So how these, there is an interaction between this drop and the early drop which is present here. So we have to do modeling for this, and we can make use of physics-based modeling for all these things. Physics-based modeling models are a bit difficult to create. It requires a lot of time and effort to create analytical models as compared to empirical models or machine learning models. The machine learning models are the next thing, but for machine learning algorithms, we need to have data because all these models are data-driven models. So we should have data available with us, a lot of data. The more data we have, more accurate results we get out of machine learning algorithms. So three type of modeling: empirical modeling, experimental models, analytical as physics-based model, and machine learning models are machine learning algorithms that we can use for predicting the quality of the parts that we produce on 3D printing. Okay, now coming to the some more research topics. We can always try for additive manufacturing capabilities. We can talk about dimensional accuracy, reproducibility, geometric features. We can also create smart algorithms for deciding which additive manufacturing technology is best for my product. So you can create softwares like that. Also, you can go for process parameter optimization. So this is related to data analytics. And these days also people have started working in sustainability. So this is again a huge domain, sustainability, quite relevant. Just to give you an example, again, I take the example of that mobile stand. Uh, so should I go for mobile? Should I make mobile stand on 3D printing, or should I still keep on doing it with conventional methods on additive manufacturing, or should I still be using injection molding? So for that, they can perform sustainability analysis. And then from sustainability analysis, they can also make it out, okay, additive manufacturing is good, or the injection molding is good. So this is also a huge domain, uh, catching a lot of attention these days. More research topics. So this is very, I would say, very ambitious project. But the university close to me as RMIT, they are working on it. So they are creating joints. You can see they're making joints like this of titanium. So now if you are creating a joint like this example, the joint it is a porous structure. The structure which you see here is a porous structure. And first thing is using 3D printing is like it's like edit. Now it's 3D printing for it's like customized. You are customizing it for a patient. So it is a customized product, and it is a porous structure. If it is installed in the body in few years, because it is a porous structure, calcium deposition will start taking place, and in few years it becomes part of the bone. It's no more an external element. It is now part of the bone. So this is a great thing which is we are able to achieve only by additive manufacturing. Now, in the beginning, I asked you a question that whether our conventional machines will be gone or not. If we talk about the enthusiasts, those who are really inspired by 3D printing, they say in 5 years down the line, we will be replacing all these conventional machines will be gone. And what they anticipate is they anticipate that at home, each one of us at home will have three machines, 3D printers, with one for metal, another one for polymer, third one could be for ceramic. And companies will stop selling products. They will be selling only the designs. So we will be buying designs online and printing the products at home ourselves. So this is what enthusiasts say. But if you see here, if we talk about metal 3D printing, so metal 3D printing, the one step, the last step is post processing. So whatever we are producing, we need to do the final processing. You can, if you see this part, it is having quite, it requires a nice surface finish and the dimensional accuracy, which is possible only by machining. With 3D printing, we'll get a rough surface, but we need to go for final finishing, which we say is post processing, and this has to be carried out on conventional machines. In this case, it is we are making use of 5-axis CNC machines, but it can be done using conventional machines also. So immediately, I don't think we'll be replacing all those machines, because for metal 3D printing, definitely we will be requiring our conventional machines for post processing. Okay. Now this is something which we have developed in-house. So we have developed one extruder. So in the beginning, I have shown you that we have FDM, fused deposition modeling, and there we are using filament which is made out of PLA. And here in-house, we have developed an extruder where we are able to produce a filament. So we are able to produce filament. This is what we have developed in-house, and this development is not very expensive. We can get all the parts from the market, and then we can machine few things, and then we can make it assemble and make it work. Another development, if somebody is having say welding machine, you can easily convert that welding machine to uh, a warm wire metal arc welding setup. This is what we did. We had uh, a GMAW machine, a welding machine available with us. So we added two controllers, two CNC controllers, so X and Y, and then we could use this machine as WAM setup. So that is also possible. So we can see what setup we have in our lab, and then accordingly, by adding few things to that setup, we can use it as a WAM. Okay, so these are some of the 3D printing machines, some of the important manufacturers. So just the list here. What software you should be using? So this is again a list of softwares, and ranking is also done, but you can use any software of your choice. My favorite is the Fusion 360, because I'm quite comfortable with this. So that is the only reason why I say that my choice is Fusion 360. Otherwise, you can pick any of the software. So all these softwares are quite good softwares for working in 3D printing. Okay, so this Fusion 360 is it's available free for students and teachers, so you can download and work on this software. Now, if you don't want to use this software and still you want to work with 3D printing, this is a very good website. So Thing I was. So you go to this website, and on this website you will find different designs. So many thousands and thousands of designs of various products are available. You simply download that design. When you're downloading, they give a certain capability of tweaking a few things. So you can customize, you can make changes, a little bit changes there, download that part, and you can print it. Now, suppose if you don't have print, but still you want to print, then so you need to go to this website, uh, Protolabs. So they have a list of all 3D printers installed worldwide. Maybe there is one 3D printer installed just next door. Whatever design you have downloaded, you have made changes in it, you send that design for printing to this company. That part will be printed and it will be delivered to you maybe next day. So you get part freshly made next door delivered to you in no time or minimum time. Of course, this is a paid service, whereas the first two are these are free softwares. But when you talk about printing, they do charge money for it. Okay, so yeah, online resources if you want to study more about this. So these are fantastic resources which are available by various universities, University of Buffalo, University of Illinois, Arizona State Universities. So these are some of the courses available through this website. And and that's it for today. And let me recap what I covered here in this session. Uh, I started with the different types of manufacturing, and then we saw what are the steps in additive manufacturing. And then we also saw different additive manufacturing technologies, how to select the technology, then research in additive manufacturing, and what tools and resources you should have in order to work in additive manufacturing. I hope all these things you might have enjoyed, and that's it. And I'm open for any question. Yeah, thank you.
So much, Dr. Vishal, with that very informative presentation. Yeah, indeed, 3D printing right now is starting to populate the industry, and we have even here in the Philippines right now, we're starting to have that one as well. So yeah, it's a very good opportunity for those who want to have careers in this particular field. So yep, let me just take control. All right. So, yep, basically, what are the courses that covers this topic? So, as you can see on your screen, we have Advanced Diploma of Mechanical Engineering Technology. We also have the Graduate Diploma of Engineering in Mechanical. We also have Graduate Certificate in Mechanical Engineering, Online Bachelor of Science in Mechanical Engineering, and then Online Masters of Mechanical Engineering. All right, for our upcoming webinars, we also have this September, we have September 3, 10, 17, two webinars. That would be first for professional certificate in vibration analysis, balancing alignment, predictive and precision maintenance of machinery, and the others as you can see on your screen. Okay, all right, so yep, let's have a short Q&A. If you have any questions, please post it on the Q&A section on the right hand corner of your screen. Mhm. Doc, as you can see here in the Philippines right now, to have this adapting, building a house using like a bigger printer using the cement. And I can see as you have presented a while ago, you're doing the like paste type, right? Yeah, I think it started to, not that popular here really, but yeah, we're starting to adapt that one. Is it part of the 3D printing as well?
Yes, it is also part of 3D printing, but domain is totally different. It is civil engineering.
It's civil engineering.
Yes, yes.
Okay, so not part of. Okay, got it. But it seems for me like the same type, right? As you
Yes,
can see.
yes, it's a similar type. So because the different technology is different, because
Mhm,
because they make use of not plastic or metals, they make use of cement. So
mhm,
cement will set quite quickly. So they need to have different kind of setup. Definitely, when
mhm.
it comes to the moment of the extruder, yes, it is
Uh-huh.
something very similar, X and Y axis.
Mm, I see, I see.
Yeah.
Yeah, that's good. Thanks, Doc. So, yep. All right. Yeah, I cannot see any questions here, Doc. I believe they have understood it well because of myself. I understood it well. So, yep. Thank you so much. And yeah,
Thank
for
you.
those who are asking actually for the certificate of attendance, here's actually the link to that. So basically, you will need to fill up a survey form, and after that, you'll be able to receive your certificate of attendance. So I'll be posting it on the chat now, okay, so that you can actually, okay. All right. So, yep. Thank you so much for your time, everyone. Thank you so much, Dr. Vishal, for that very
Uh,
informative presentation. And I think that concludes our day. Yeah. Thank you so much for joining us today. And yeah, thank you so much and have a good one.
Thank you.
Bye for
Thank
now.
you. Bye bye. Bye bye.